Hello, my name is Isra. I'm going to be doing a demonstration on problem number 24 from chapter 6. And let's go ahead and read the question. It says, consider this question. What is the mass of the solute in 0.500 liters of 0.30 molarity glucose? And it gives us a formula for glucose, which is C6H12O6, used for intravenous injection. So I went ahead and wrote a few steps over here on how I like to approach this kind of problem. Step number 1 says read the question carefully and determine what is being asked. If we go back to the question, we can determine that what is the mass tells us that the mass is what they're asking for. Number 2, determine what information is given. If we continue reading the question, we can see that the information that was given to us was the 0.500 liters of solute and 0.30 molarity glucose. So that gives us volume and molarity. If we go back to step number 3, use a formula to determine what is being asked, in this case, mass. So if we look at what information we know that we have mass, we know that we have volume, and we know that we have molarity. Looking at all three of those, we know that the formula that we would most likely be able to use for this kind of question is the formula that says molarity equals mole of solute over liters of solution. Step number 4 says, manipulate this formula to solve for our what, which is mass. We want to determine moles because moles is a unit of mass and is in this formula. We can later convert moles to grams to obtain our mass of solute. So we go ahead and manipulate this formula and turn it into moles equals molarity times volume. Number 5 says, plug in the given information into the formula to obtain our answer for moles. If we go ahead and plug in that information that was given to us in the question, the volume and the molarity, into this formula, we can go ahead and obtain our moles. We simplify the equation and obtain your moles of solute. Number 7 says convert moles to grams. Make sure you keep significant figures in mind. And number 8 says answer is your mass of solute. We can go ahead and do the problem. Okay, so first let's go ahead and we already read the question. We did step number 1. Let's determine what information is given, which is the volume and the molarity, so we can go ahead and write that out. Let's write down 0.500 liters and 0.30 molarity of C6H12O6. Number 3 says to use a formula to determine what is being asked, in this case mass. We can go ahead and use that formula that we determined in our steps. So the formula says molarity equals mole of solute over liters of solution. If we look at a formula, we can see that what we want is moles, but what we're getting is molarity, which we already have. So we would have to do what it says in step number 4. We would have to manipulate that formula to obtain our moles. So let's change that by multiplying both sides by liter. These would cancel out, and we would end up with moles equal liters times molarity, or we can write that as volume times molarity, or molarity times volume. So now that we have the formula manipulated in the way that we need it in order to obtain our moles, which will get us our mass, we can go ahead and plug in the information that was given to us. Moles equal 0.500 liters times 0.30 molarity glucose. Alright, so if we go ahead and multiply 0.500 times 0.30, we're going to go ahead and get 0.15 moles. Now, what we have to do after we get the moles is, if we look back at our steps, number 7 says convert moles to grams and make sure you keep significant figures in mind. So let's go ahead and convert our moles to grams. 0.15 moles of C6H12O6 times, because we want to get grams and we want to cancel out moles, we're going to put mole on the bottom and grams on top. And 1 mole would equal how many grams of glucose. So if we go ahead and we do that computation, we would say carbon would be 6 times 12.01, because that is the weight of carbon. And then we would do hydrogen, which is 12 times 1.008, and you can get these values from the periodic table. And then we do oxygen, which is 6 times 15.999. And the reason we're doing 6 for carbon is because the formula tells us that there's 6 carbons. The reason we're doing 12 for hydrogen, because the formula tells us, and so on. Once we do this computation, we'll know that our total comes out to about 180.14. Okay, and that is going to go right up here. Okay, and now we're going to go ahead and we're going to cancel out our moles. And now that our moles are canceled out, we know we're going to get our answer in grams. I'm sorry if this is a little confusing right here. So when we do this computation, we're going to multiply 0.15 by 180.14, and we'll go ahead and get 27.021 grams of C6H12O6. Now let's make sure our significant figures are good. So we multiplied 0.15, which has 2 significant figures, by 180.14, which has 1, 2, 3, 4, 5 significant figures. But the lower one is a 2, so we want to have 2 sig figs. If we go ahead and round that to 2 sig figs, we're going to have 27 grams of C6H12O6. And so that becomes our answer. Mass of solute. And if we look back at the question, that's what the question was asking us. And we're all done. I hope this video helped some of you out, and that's it. Thank you.